I am not really certain if you remember or not, but when we were looking at the etc directory earlier, we could see the etc directory had a hard link count of 111, and you are going to learn the relationship between the hard link count and the set directory count. Let's remind ourselves then of that listing, ls minus ld for the directory /etc. We can see then that we do, in fact, have that number 111 that represent the hard link count. We have 111 names linked to the same metadata. This includes some additional information. Let's include the option A. The option A is going to show the inode number or the directory entry, the representation of what we mean by the metadata. This is entry 8388737 reporting for register. If we look at the directory /etc/dot, I think a lot of people don't really think of this as a directory. We just think of it. It's the current directory. The directory dot, no, it's a file in the file system. As such, then it's going to be linked to the same metadata. But look, it's linked to exactly the same metadata as the etc directory. So yes, it's a representative of the etc directory. When we create a directory within that directory, we are always going to have a dot file. That dot file represents the current directory. The minimum hard link count for a directory is going to be 2. When we have two names, in this case, etc and dot, are pointing to one set of metadata. We will also have a file called dot that then linked to the parent directory. Hence then we can read from this etc directory that we do. Let's take a look at this a little bit more. If we go through and go amok there, and then we can have, let's say, T1. Then let's go through and do an ls minus ld for that directory that we have just created. We can see then that it has a hard link count of 2. When we look inside the directory, so ls minus l and t1, we don't see anything, but put the option A up. But put A option, we can see our hidden files. Now we can see that it contains then dot and dot. These are files, or at least file names that are linked through to the metadata. This dot is linked through to the T1 directory metadata, and dot is linked through to the parent directory or my home directory. Again, we can see this by doing an ls minus lda on T1 and on T1/dot, same as we were doing with the etc directory. We can see that we have got exactly the same metadata entry. If I start to create set directories, let's go through and do mark there T1 then /s1. Now when we go through and look at those directories, let's just look at T1 directory. Although T1 and T1 dot directory will be the same, we have now got a hard link count of the 3. That's because in the sub1 directory S1 we have a directory dot that points to the parent directory. T1 dot again and go and repeat this. Let's create sub2. Repeat the long listing. We now have a hard link count of 4. This becomes a really easy way and great party trick. I said to be able to instantly be able to identify how many subdirectories a directory has. Now our hard links are okay, but they are limited to the same file system. There is nothing stopping me going through and let's create a sample file with text. If I echo the word hello through to the file, we'll just call it F1. If I cat F1, it will just say hello. That's the content of the file. If I log ls minus l on file 1, we can see it has a hard link count of 1. If I go through and do an ln and link the file 1 through to the file 2, this is our hard link that we are creating. When I do an ls minus la on file 1 and file 2, we can see now they're both shown as having a hard link count of 2. But take a look at the inode number. The inode number is exactly the same. They are in fact exactly the same file that we are pointing through to, but they do not show as links. They are regular files. Well, when I go through and cat F1 or cat F2, of course, we see exactly the same data because the names are linked to the same metadata, and the metadata itself is then linked through to the file. Whereas if I did this ln minus s for symbolic link, and then we are going to link the file 1 and we are going to call it this file 3. Clear the screen to give me some room. Then go back and take a look at a long listing of file 1, file 2, and file 3. We will include the inode number. The first two files, file 1 and file 2, we can see they share the same inode number, and we can see they have got a hard link count of 2. When we look at the permissions block, they have a minus as the first character, so that's a regular file. But then take a look at this third file, completely different. F3 different inode number. It's incremented now. It's the text file and the file system. It's of type link and has a hard link count of 1. We can see that actually metadata also include the information of where the file is pointing to. This is a separate file who is just pointing through to the path of the original file 1. If I go through and cat F3, of course, it behaves the same as the others. We are just pointing through. The advantage of symbolic link is I can cross file system boundaries. A hard link, for example, won't allow me to cross into the boot directory, which is a separate file system. If I go through and try create a link to, let's say, the kernel file, and we will do it to the current directory, we can see it's an invalid cross-device link. Whereas if I up arrow OK and create a symbolic link, there are no dependency on the same file system now, because we are pointing through to the separate file system rather than sharing data within the same file system. Now when I do an ls minus l in my current directory, we can see now that I have got a symbolic link that points through to the boot directory. This is what we saw earlier when we were looking at the etc directory, and we're looking at the system release file being a symbolic link to the CentOS -release, as was the Red Hat -release. This is a really easy way to allow users and administrators to refer to a file within virtually any name and keep consistently across systems through updates or name changes. Hopefully we have got some of the basic of working at the command line and understanding some of the things that we can use to speed up our use of the command line and the file system. Let's just tidy up what we have been looking at with a nice summary.